29 is the primary series from Irving Primary School. This lesson will go on with the methods of limit calculations. So over here we have one question, okay? So let me first write down what's the question. The question which is limit x approaches to positive infinity 2x squared times 1 minus cosine 1 over 2x. So it will sub in. Here become cosine 0, 1, 1 minus 1, 0. Here infinity. So this is the indeterminable form infinity times 0. Although 0 times infinity and infinity times 0 are the same, but the order matters. It's about your mind. So for the first method, it's quite simple. So for the first method, we are going to use the special limit. Okay. The special limit number what? 1. So let me put down what's the special limit number 1, okay? Which is limit x approaches to 0 sin x over x, which equals to 1. The number 1. So here, what shall we do? So over this part, infinity means positive infinity. So here, let's see. So this part will need to use the double angle formula. What is the double angle formula? Okay, so first, you know that cosine 2x equals to 1 minus sine 2 sine square x, right? And then here, so then why don't I choose the cosine minus 1x? I'll show you why. So that means 2 sine square x is equals to 1 minus cosine 2x. So like this, the cosine 2x. So this part will need to times of 2 sine square 1 over 4x. Like this. So let's see what form is this. This part infinity, this part 0. Again, infinity times 0. So, if you have noticed that we can take out 4 here, and then after that, the denominator, which becomes like this. So we already have an x squared, so mainly we need the 4. So 16 here. So this part, special limit 1, 4 over 16, simplify, 1 over 4. So the answer is 1 over 4. Quite simple, right? So let's move to the next method. Method 2, we need to use the variable substitution. So this is called the variable substitution. Also, we are going to have a third method which also has variable substitution, but the third method main focus is for the L'Hopital's rule, okay? Oops, no, it's that. So what shall we let? Best is to let go 1 over 4. Because that, okay, if you notice like this, which for x equals to 1 over u, wait, and then here x which equals to 1 over 4u, then u which approaches to 0, plus, because that this is a positive infinity, and then here, next step, sub it in. So here 2x squared change to 1 over 8u squared. As f is 4, because the f is already have a 2, so simplify. And then here, let's see. 1 minus cosine, 2u. So this part the good part, perfectly the same way. Wait. Like this. And then here, you already notice special limit number 1. This one got you special limit number 1 and the variable substitution. And then here plus and plus. And then the time 2. Again. So, for our last method, it will be special. We although still gonna use the variable substitution, but mainly we'll use the L'Hopital's rule. So first get a quick look here. It's not much about here anyway. So can I erase? Okay. So here we still need to let. This time instead of letting 1 over 4, which become more complicated if we done that. So this time there 1 over 2x equals to u. Then 2x equals to 1 over u. The x which equals to 1 over 2u. And then u which approaches to 0. Plus, and then here limit from x becomes u. U approaches to 0. Then after that, here we need to change it to a fraction, which this part 1 over. So at first there's a 2x squared, right? So it become 1 over 2u squared. And then numerator, which has the 1 minus cosine whatever, that part becomes u. And then, you know, in the L'Hopital's rule. Why is it the L'Hopital's rule? 0 over 0. That's why. Like this, and then like this. After that, we show special limit number 1. And then 1/4 again. Okay, so like this. Okay, so now we'll end here. So next time we'll continue. If you like our video, don't forget to subscribe to our channel. Tune in for more, and thank you for watching.